All right, welcome back, guys. Hope everybody had a good Thanksgiving break. It's good to see everybody, and we have a perfect attendance first day we come back, so that is fantastic. Shows me that a lot of people missed math and wanted to get right back into it, I'm sure. Yes, of course. All right. So, did you forgot what? Triangle is? I will help you out with that. Okay, so you'll notice we are not going to be doing happy minutes for a while. We've finally gotten to where we're past evaluating trig functions on the unit circle. Now the next set of happy minutes is going to be revolved around the trig identities, but it's going to be at least a couple of weeks before we get to those. So in the meantime, we're going back to focus activities. I've already got three already printed and ready to go. Hopefully, we'll get a fourth and a fifth, and we'll just kind of see how far we're able to get. But just like we did in the first and part of the second 6 weeks, hang on to these, keep someplace safe, and at some point in 2 or 3 weeks, I'm going to have you turn them in for a quiz grade, and it should be just a really easy quiz grade. We'll work them together. You just have to hang on to them. Now, speaking of grades, we do have 4 weeks, this week included, until the end of the first semester. So if your grade is a little lower than you would like, or if you're in danger of failing the semester, these last grades, we really want to make sure they're as high as we can possibly make them. Please stay on top of your homework assignments, quizzes, and tests. If you ever have any questions, come on in. Let me help you with that. Speaking of tests, Friday morning is going to be the deadline if you want to retake the test we took before the break. Okay, I believe I passed those out before you guys left. Quizzes. On Wednesday, you're going to have a graphing quiz over sine and cosine. And it's actually going to be very similar to this. In fact, number 1 on your quiz is going to look like this. It'll be sine or cosine. It's just going to be a different transformed function. So I thought, it's been over a week since I've seen you. This would probably be a great way to start back, showing you exactly, what's going to be on your quiz. All right, so that's coming up on Wednesday. Now, the big one, okay, because we're talking about, final grades, and we're going to start to get everything kind of wrapped up. Next Friday, a week from this Friday on December 7th, that's when your second exam is going to be. So it's going to have everything from graphing, sine and cosine. This week, we're going to be spending our time talking about how to graph tangent and cotangent and all the others, okay? So we're going to be practicing that. And then after that, we're going to move into inverses. But I don't know how far we're going to be able to get on inverses, so the test may just be on graphing all these trig functions, but we'll kind of see how that plays out again. We'll see how far we're able to get. And then really that last week is just going to be review. We got to take care of the district assessment. And then Thursday and Friday, the 2 final days are half days where we take our finals. Hey. This coming Monday, yes, but in 2 weeks, no. So I want to say that's December 10th. December 10th, the Monday after we take our test next week, that is when you get a 3-day weekend because we have content focus session. So not this coming weekend, but next weekend, you have 3 days off. All right. Well, good. Let's see what we got here. Before we go ahead and move on with the next lesson, it says determine the following information about the given function. Okay, then find 5 coordinates in 1 period, sketch the period, calculators. Okay, we don't need those today. So when we're looking at a transform function, A is always what we multiply the trig function by. Okay, B is always the coefficient of x. Now C is what we add or subtract to x, but here there's no phase shift, a horizontal shift. So there is no value of C, or it's 0. And then D is what you add or subtract to the function. Okay. Now, one quick question. How do we know the difference between something done horizontally and something done vertically? The parentheses, that's a big red flag. Look for the parentheses. Anything in parentheses is going to be horizontal. If it's not in the parentheses, then it has to be vertical, like in this case, A and D. So B and C are typically going to be your horizontal transformations. Okay, let's go ahead and run through these expressions real fast, because again, it's been a little over a week since I've seen you, and we want to refresh ourselves. Now, the midline, we always write it as an equation, but we use the value of D to help me with that. Okay, we'll come back right now. We're just going to write the expressions. Okay, for the amplitude, does anybody remember that expression? What was it? You're already making the 2 bars. Yes, absolute value of A. Yes. The absolute value of A. Nathan was making the gesture with his hands. He was correct. Now, does anybody remember the period? I know it involves B. 2 pi over B. There we go. So I'm going to take 2 pi and just divide it by B. Now, the frequency, what I'm actually going to go ahead and talk to you a little bit about today, that means the reciprocal of the period. So if the period is 2 pi over B, well, then the frequency is B divided by 2 pi. That's exactly right. B divided by 2 pi. Now, I'll explain a little more what this means when we get to it, but really, it tells you the number of times you should see the graph repeat in a given measure. Okay? And then our pattern of critical points, we'll talk about that kind of sine and cosine. So just like on your quiz, you're going to have a little grid here. You've got a little table to go ahead and fill in your ordered pairs. So let's go ahead and find this information first, and then we'll go ahead and find our ordered pairs and sketch it. So the midline, I said that revolves around D. Well, what's the value of D here? Yeah, -3. But the only thing is you always want to write it as a what? That's it. He says y equals. We always want to write it as an equation. So y equals -3. Remember, the midline goes horizontally halfway through your graph. You can really see where the altitude is. Now, speaking of, or excuse me, amplitude, there you go. A is -1. The absolute value of -1 is 1. Now, what was the value of B from my function? B is equal to 4, right? So I'm going to plug it into this expression. This would be 2b over 4, but that simplifies to pi over 2. So every pi over 2 radians, I should see this graph repeating itself. Okay, we always want to simplify. All right. Now, the frequency is just the reciprocal of the period. So if I got my period to be pi over 2, then it's just 2 over pi. Yeah, you simply swap the numerator and the denominator. So this is 2 over pi. And again, I'll come back to this in just a moment and talk to you about what that really means. Okay. And then pattern of critical points. Now, we used a mixture of zeros, maximums, and minimums, but when we're dealing with cosine, what did he start with? 0 or a maximum? Cosine always started with a maximum. Okay, so 1. Then he had a 0. Then a minimum. 0 and a 1. So if you're trying to visualize this, pretend this is the midline right here, what cuts your graph in half. So you started with a maximum, you went to 0, to a minimum, back to a 0, and then to a maximum again. So you always have that curvy V when you're dealing with cosine. Remember, sine started at a 0 and looked like that. Okay. Well, good. Are there any questions on filling in that first table? Again, this is exactly what you're going to do in 2 days on Wednesday when you get your quiz. All right. So now let's go ahead and find the x's first. Now, in order to do that, I remember we set up something called a compound inequality. Okay, now my compound inequality, we always put less than or equal to, and we put it between 0 and 2 pi. If you're going to graph sine or cosine, we always put it between 0 and 2 pi. Always. Okay. Now, what goes in the middle of that? 4x. Remember, whatever's in parentheses. Okay, whatever's happening horizontally. So I put 4x right here in the middle. Okay, now that's great, but I don't want 4x in the middle. I want x. There you go. So whatever you do in the middle to get that x by itself, you do the same thing to the other two parts. So 0 divided by 4 is 0, less than or equal to x, because, 4 over 4, which is less than or equal to, yeah, we just saw that a second ago. 2 pi over 4 is pi over 2. Okay. So now I've got my compound inequality ready to go. Okay, we're going to leave him alone for just a second. Now let's turn my attention to these critical points. Is there anything happening vertically? What? So the -3, so everything shifted down 3, and then the negative reflects it. Now again, how do I know those are vertical and not horizontal? They're outside the parentheses. So each of these 5 right here, I want to first multiply by -1, and then I'm going to subtract 3. So let's start with this first one. 1 times negative 1 minus 3? That would be negative 4. So I'm going to put a negative 4 right there for my first y value. Okay. Now move on to the next one. 0 times negative 1 minus 3. That's just negative 3. And I got a text message. Okay. All right. For the next one, negative 1 times negative 1 is 1, and then 1 minus 3 is negative 2, just like Nate said. And then you'll notice 0 will give me another negative 3, and then 1 will give me a negative 4. Is everybody okay where those came from? Is anybody not sure? Okay, Brandon, what can I do to help? Okay. Are you okay with these critical values? Okay. So we're taking these two transformations, the ones that are outside the parentheses, the negative 1 and the negative 3, and I'm applying it to these one at a time. Like the 1, I'm saying 1 times negative 1 minus 3. Well, that would give me negative 1 minus 3, which is where we got the negative 4. Okay. Now we move on to the next one, the 0. So I would say 0 times the negative 1 minus 3, but 0 times anything is 0, and 0 minus 3 is negative 3. So see, I just took these one at a time in order and applied those two transformations to them. Okay. And see, when I got back to the 0 and the 1, that's why it was able to give me the same answers. Does that make sense? Okay. Good. All right. Now, we got the y values. Now, that's great, but how does that compound inequality now help me finish in fill in the rest of the table? Okay. Now, this lower boundary right here, you always pair it with the first critical you got. The upper boundary, you always pair it with the last critical value. So see, right here, this is already giving me two ordered pairs that should be on my graph. I know we have 0, negative 4, and then pi over 2, negative 4. We can even go ahead and graph those if you want. So 0, negative 4 would be right there. And then here's pi over 2, and then negative 4. So we've already got those two taken care of. Now, how am I going to find the x's that are missing? There you go. Now here, we can see the distance from 0 to pi over 2 is pi over 2, right? Now, Alizé hit it right on the head. We always divide by what? 4. Well, we always divide by 4. Yes. Now, the only thing you got to be careful of, sometimes when you simplify this compound inequality, you know, the lower boundary won't end up being 0. If it is something besides 0, you'll have to subtract the two boundaries and then divide by 4. Okay? So, you know, don't forget about that. So what is pi over 2 divided by 4? Let's think about this. Pi over 8. Yes. That's right. It's going to be pi over 8. Okay. Now the grid is set up to help me with this. What's halfway, this one right here, between 0 and pi over 2? That would be 1/4 pi, right? So where is pi over 8? There you go. So pi over 8 would be right here. Okay. All right. Now, we found pi over 8. This is the value that I'm just going to add over and over again, and I should be able to get to pi over 2. Now, if it helps, you can go ahead and just write it out using a pattern and then go back and simplify. Here's what I mean. 0 plus pi over 8 would give me what? Pi over 8, right? Well, now, pi over 8 plus another pi over 8 would be 2 pi over 8 plus another pi over 8. 3 pi over 8. And now let's add it one more time. 3 pi over 8 plus pi over 8. Now that would be 4 pi over 8, right? But what does 4 pi over 8 become? Pi over 2. So see, now I can just go back and simplify. So the 4 pi over 8 became the pi over 2. Is there any other one that will simplify? That becomes pi over 4. There we go. So if it helps you to write it out using the pattern and then go back and simplify, absolutely. Or if you like to simplify as you move forward, perfect. Now, any questions on where I filled in the rest of that table? No? Okay, well, let's go ahead and graph these. So first I want to go pi over 8 to the right, and then I'm going to go down to -3. So I'm going to have this point right here. Then I'm going to go pi over 4 right, -2. Now, where would 3 pi over 8 be? There you go. It'd be halfway between pi over 4 and pi over 2. And at that x, we want to go to -3. So there we go. This would represent 1 period of this transformed function. Okay. Now, what if I say wanted an extra period? How would I do that? Yeah, just repeat the dots. The pattern will never change. So here I got a minimum, so the next one would be a 0, then a max, then a 0, then a minimum. Now, can I also go in the other direction? Yeah. So I have a minimum here. That means the next one would be a 0, max, 0, min. And I mean, we can keep going as many times, as we want. Okay. But there we go. That is, what are we trying to do? Negative cosine of 4x and then -3. Okay. Exactly what I'm going to have you do on your quiz. Okay, questions. Okay, now let's go ahead and kind of confirm some of our answers. Let's see if we're right. Now, one of the things, let me go ahead and point out before I forget. You remember how when I was writing these out, I would say minimum, maximum, and 0? These points right here, I said, were zeros. Well, if there's a vertical shift, when I'm referring to them as zeros, I'm referring to where the graph would cross the midline. So those can still be represented as zeros. Okay. So here's my midline, y equals -3. So we were correct about that. The amplitude is half the height. Yes, sir. If we have time at the end. Okay. So you can see half the height is 1, so we were correct about that. This should repeat every pi over 2 units. So let's see, here's 0, here's pi over 2. So do I see the exact same thing in the next pi over 2 units? Yeah. Okay. Now here's what the frequency is telling me. It's 2 over pi, right? Okay. What this is telling me is the number of times it's going to repeat, the number of cycles you're going to see over a given measure. Okay. So what this is telling me is that in a length of pi units, it should repeat itself twice. So let's check that real fast. Let me go ahead and use a different color. Well, here's 0. Here's pi, right? Let's take a look at my graph. How many times does it repeat itself in the pi range? See, there's 1 and there's 2. That's all the frequency is. It tells you the number of times it should repeat in a given measure. Okay? And you get that from taking the reciprocal of what again? I keep forgetting. Ooh. Well, the frequency is the reciprocal of the period. There you go. Is this starting to come back to you guys? Did we miss it? Of course we did. Yay. All right. But this is what we're going to be looking at on Wednesday during your quiz. And remember, you can always use your what? You can always use your notes. So this is really good to have on that day. Okay. Well, good. We are not doing inverses just yet. That is IS. All right, this is the stuff you guys picked up today. All right, so I just want to kind of introduce you to this idea of frequency because I just kind of brought it up. I really didn't mention it the week before we left, but any transformation of a sine function is called a sinusoid. Okay, we call it a sinusoid. Now, what you're going to come to find out is that all 5 of the other trig functions besides sine, cosine, tangent, and the other 3, they can all in some way be related back to sine. So these are what we just call sinusoidal functions. If you can transform a sine function, we call it a sinusoidal. Okay. This is just terminology that you may encounter, as you move forward for those of you who are going into calculus. Okay. But here are my general forms. We've got a times the function. B is the coefficient of x. See, C only exists if you add or subtract 2x. And D is always outside the parentheses. You add or subtract to the function. Okay, so if I were to give you something like this, let's say, 2 sine of 2x plus 5. And now let's do the same thing here. 2 sine of 2x plus 5. Okay. Well, will we agree that a is 2? That's the same. Would we agree in both cases that b is 2 as well? Okay. Now, what's this 5 right here? Okay. Now, Antonio says d. So that means this one is d as well? Why not? It's the same thing. The parentheses, and that makes all the difference. Okay, this would be c here. So in this case, there would be no value of d. D is 0. But in this case, there is a vertical shift. There is no value of c. So you always want to be on the lookout for those parentheses. They tell you horizontal and vertical. They make it real easy. Okay. Now, the frequency. The frequency of a sinusoidal function is the number of cycles the function completes, the number of times it's going to repeat in a 1-unit interval, whatever you have. The frequency of the reciprocal is the period. Now, in some textbooks, they might use lowercase letters, as in this resource that I pulled from here, and they might even have b in absolute value. I'm not going to put absolute value on b when we're talking about the period or the frequency. We're just always going to take the positive version of it, okay, no matter what it looks like, always positive. So the frequency is just the reciprocal of the period. So let's take a look at this guy right here. Okay. Now this is just the parent of sine, the original graph. Okay. What's the period for sine and cosine normally? It's always 2 pi, right? So the period of this graph is 2 pi. All right. So the frequency, what's the reciprocal of 2 pi? 1 over 2 pi, right? Okay. So what this is telling me is that I should see it repeat just once in how big a distance? Yeah, in 2 pi. So if I look at the graph, here's 0, here's 2 pi. I only see 1. It doesn't repeat itself at all in 2 pi units. Okay. Just like on the previous one. Remember, it was 2 over pi, so I saw it twice in that pi length. Let's look at this one. Okay. What's the value of b here? Because this is the graph of sine of 3x, right? Okay, we've got parentheses. So b is equal to 3. So what's the period of this graph? 2 pi over 3. Because remember, it's just always 2 pi over b, right? This thing will let me write. There you go. Now the frequency is going to be the reciprocal of that. 3 over 2 pi. 3 over 2 pi. So what this is telling me is that how many times should it repeat? I should see it repeat 3 times in how big a distance? In a length of 2 pi. Well, let's take a look. Here is 0. Okay, here's 2 pi right here. So let me go ahead and use a different color to kind of help you out with this. So in this region, I should see it repeat 3 times. Well, there's 1, there's 2, and there's 3. That's why the frequency is written as 3 over 2 pi. It's the number of times your graph repeats in a given measure. That's all the frequency is. Okay. Does that make sense for everybody? Okay. So if you had a frequency of, say, 5 over pi, what is that actually telling you? You should see it repeat how many times? 5 times in how far a distance? Pi units. That's pretty skinny. Okay. Good, 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 good. All right. Well, let's go ahead and start taking a look at these other graphs right here. Okay. Now, tangent and cotangent are going to be really the only ones that are going to be really different. Secant and cosecant are actually surprisingly going to be really easy because we already know about sine and cosine. Okay, but we'll get to the characteristics in just a minute. Let's go ahead and talk about the graph. Let's see what tangent looks like and why he looks the way he does. It says the graph of tangent function will complete 1 full cycle on this interval between 0 and pi. So the period of tangent is pi. Remember, what's the period for sine and cosine? It's always 2 pi. So it only takes pi radians. This graph of tangent has already repeated twice by the time sine completes 1 cycle. Okay, he's repeating twice as fast as sine or cosine would be. Okay, now here's the form. A tangent of bx minus c, and then of course you could have a d out here. But in order to go ahead and graph tangent, let's go ahead and do him in terms of sine and cosine. Okay, you remember when we're evaluating on the unit circle? Let's say we have tangent of x equals, okay, what's tangent's ratio? It's always y over x, right? Would everybody agree? Y over x. But we know by now what trig function is y. That's sine. And what trig function is x? That's cosine. And this ties back to the definition a moment ago. You remember how we said any transformation of a sine function is called sinusoidal? Well, you see how I'm rewriting tangent in terms of sine? Even though cosine's there, it still involves sine. So in some way, you're going to be able to connect these back to sine. Okay. Well, I'm actually going to use cosine to help me out with this. And there's a reason why I'm going to go in the denominator. But I'm going to start, let's draw cosine very lightly because we're going to erase him. Okay, but where does cosine start? Is he a maximum or a 0? Remember, he starts at a maximum. So cosine starts at 1. Then we have a 0, then a minimum, then a 0, and then a maximum, right? Okay. And I know what you're thinking. We need to graph tangent. Okay, we're not trying to graph cosine, but just bear with me. It's going to make sense in a second. And I can do this in the other direction. So I have a 0, a minimum, a 0, and then a maximum. So remember, we want to draw this very lightly. Oh. There we go. Kind of moved over. Okay. All right. Now, all other graphs besides sine and cosine, they're going to have something that sine and cosine don't have. It's been a while since we've seen these. You think what I might be talking about? Starts with an A. Tangent, cotangent, secant, and cosecant, their parents are all going to have asymptotes. Now, see, here's the thing. For tangent, it's a big problem when cosine is what? Why can't cosine be 0? That's exactly right. Okay. Nathan just said cosine can't be 0 because then tangent would be undefined. That's the one thing you cannot divide by. You can't divide by 0. So wherever cosine is 0, what is tangent going to have? He's going to have an asymptote. So wherever cosine touches the x-axis, like right here, tangent's going to have an asymptote. He's undefined there. There's also another 0 at negative pi over 2, pi over 2, 3 pi over 2, and it's just going to keep going. Okay. There we go. Now I'm going to go ahead and erase cosine because I don't need him in order to continue. And again, why didn't I try to graph tangent using sine? Why did I focus on cosine? There you go. Their zeros are in different places. And cosine is going to tell me where tangent's undefined because we can't divide by 0. Okay. Now, the x-intercept is always going to be exactly halfway between these asymptotes here. So what is exactly halfway between negative pi over 2 and pi over 2? 0, right? So that's its intercept. Okay. What's exactly halfway between pi over 2 and 3 pi over 2? Pi. So the x-intercept for all of these are going to be exactly halfway between every set of asymptotes that you come across. Okay. Now this other one I'm just going to go ahead and give to you because you're not really going to see how it comes about until I go to the unit circle. Okay. What's this right here? What's halfway between 0 and pi over 2? Pi over 4, right? At pi over 4, tangent's going to give you 1. What's halfway between 0 and negative pi over 2? Negative pi over 4. At negative pi over 4, tangent's going to give me negative 1. So that's what tangent looks like. Okay, now you're probably thinking, where did I get the 1 and the negative 1? Just kind of hang in there with me for 1 minute, and I'm going to make the connection. Now, if I wanted to see the other periods, well, what can I do? What have we always done? Just copy the what? Yeah, just copy the points, right? So if I've got 1 here, I know that I need to go 1 right, 1 up, and I need to go 1 left and 1 down. I'm just following the same set of dots that I had from the previous one. I'm just copying it. I'm going to do the same thing over here. I know that I need to go 1 right, 1 up from that intercept. From this intercept, 1 left, 1 down. And how far is this going to go? This is going to keep going forever. I would have another one right here. I would have another one right here. You know, as far as we can fill up the graph. There you go. This would just keep going forever and ever. Okay. Now, you remember how we had critical values, the y values for both sine and cosine? Well, we're going to have critical values for tangent and cotangent. Okay. In order to graph tangent and cotangent, you have to start with a consecutive pair of asymptotes. What does that mean, consecutive? Like if I have consecutive numbers, how's it? Not repeats, it means they are in, I don't know if anybody said it, I haven't heard it, order. Okay. They're increasing. So one right after the other. So I have to use a pair that are right next to each other. So let's focus on this guy right here. Okay. Now the critical values for tangent and cotangent are going to look a little different, you know, because we have asymptotes. I'm going to go from one asymptote to the other. So what are we going to go ahead and use to represent an asymptote? Well, we're going to put the no solution symbol. Okay. And now we're just going to follow the points on that curve that I created for you. What's the y value right here? 1, but it's a -1. Then what's the y value here? Ooh, not yet. That's 0. And then now for this one, we get to what? +1. And then we finish up with what? No solution, because we're back to an asymptote. See, that represents one period for tangent. Okay. That's going to make it really easy for us to graph these. Okay. But let's see, why do we have the points that we do? Like, why do we have, 0, 0? Why did we have pi/4, 1? Uh-huh. It's going to be very similar, yes. In fact, let's think about the unit circle. Now, you'll notice these increments are going in pi/4, right? Because pi/4 would be right here. So let's start with 0. Okay? Let's say we're looking at a unit circle. Now, remember, tangent, he always wants y over x, right? So let's start at tangent of 0. We'll add 0 radians. Okay? I want to take the y value and divide by the x value. So what's 0 divided by 1? 0. So see, this gives me the ordered pair 0, 0. And now let's start rotating in increments of pi/4. Okay. Tangent of pi/4. Okay. Well, here's pi/4. I want to take this y and divide by this x. So square root of 2 over 2 divided by square root of 2 over 2. But what's that? 1. So it's going to give me pi/4, 1. Okay. And isn't that exactly one of the points that we just found? So let's rotate another pi/4 where we get to pi/2. Oop, wrong way. So now another pi/4 radians. So tangent of pi/2. Okay. But what's 1 divided by 0? Undefined. See, that's why at pi/2 we have our first asymptote. Because you can't evaluate tangent there. Now let's go ahead and try the other ones. If I go another pi/4 radians, then I'm to this guy right here. So I want tangent of 3 pi/4. Well, what's this y divided by this x? -1. So see, that gives me the ordered pair 3 pi/4, -1. That's all. And let's go one more. If I rotate another pi over 4 radians, where am I? I'll end up with an asymptote. Yes, you're right, because we're at pi, right? So tangent of pi, well, what is? Yep. Okay. So you're saying this one would be 0, not undefined? 0 divided by -1 would be what? 0. So what ordered pair would that give me? Remember, we put in a pi, and what did we get out? So let's see. The next set of ordered pairs should be 3 pi over 4 -1, and then pi 0. So then we got 3 pi over 4, 1, okay, and then pi 0. There we go. See? Then I'm willing to bet if we continue to rotate, we're going to get those asymptotes and those same 3 points over and over again. You remember how we did the same thing with sine and cosine? I related it back to the unit circle. It's just the unit measure you have as you go around. Okay. And then I've already got this filled in for you right here. Okay. The domain is all reals, but we have to exclude all those locations that are asymptotes. Okay, we can't include where tangent's undefined. So you'll notice right here, let's say we start with pi over 2. How far is it to the next asymptote? What's the period for tangent? It's just pi, right? So how far is it to the next asymptote? Pi. The next asymptote after that? Pi. Well, you'll notice I started with the first asymptote, and I'm just adding multiples of pi. Here we're using the variable k, just like we did before. We're just saying that k is a, what's that letter Z? Starts with an I. It's an integer. So it's your positive counting numbers, 1, 2, 3, and so on. 0 and their opposites. Okay. Now, why is the range negative to positive infinity? Yeah, you'll notice there's no upper or lower boundary on this. I can go forever. Okay. The x-intercepts, those are in multiples of pi. So 0, pi, 2 pi, and so forth. The y-intercept is 0, 0. Now, what's odd symmetry again? It says symmetric with the origin, but what does that mean? Because I don't see a line of symmetry. That means if I were to do what? Now reflect it, rotate it. So pretend that 0, 0 right here was like a pivot point. If I were to rotate it 180 degrees, this minimum would become that maximum and vice versa. Okay. The asymptotes would also be in the exact same position. Okay. And then the asymptotes are just listed where, we had to exclude the domain. Okay. All right, so how are we doing? Good? All right, I'll tell you what, it's a lot for the first day back. Tomorrow, we'll go back over this. We'll start looking at how to graph these things. And I'm telling you, it's real easy. If you knew how to do sine and cosine, you're going to be fine, okay? Just bear with me. All right, thank you so much, guys. Great job as always.